Good morning, lovely 12s. Right, buddies, this is it. You've made it. You've finished the entire Year 12 Trig unit, which is one of the trickiest units going. And as promised, this is our last lesson, and it's going to be a great big revision lesson for you. So it's got all sorts in it. It's got cosine law and sine law. I've put those toward the end because I think you need less practice at those. But more importantly, it's got things like trig identities, which are tough as nails. It's got solving, and it's even got solving when the period is different, which is what this question is here. So I'm not going to try to make a very long video at all, so I'm just going to try to get a wriggle on here. I just thought, like, if you want to skip ahead right now and get the questions, they're going to be under this black box in the bottom. If you want to try this question with me, because I picked this just because it looked hard to me, to get yourself back into the swing of things, you could try this one ahead of me, and then yeah, if you could try this one ahead of me and then see if you get caught up, that's probably the best thing to do. And yeah, and if you'd like, you can skip right to the very end and just do some practice today. So check out what's under this black box at the end of this video. So that's it, my buddies. Let's see if we can do it. Ready, ready, ready? Let's do it. Okay, so just to remind you then, really hard, one just really hard question, and then I'll let you get on your way. Okay, one hard one to make sure you've got the idea. Now, to start with, they've already messed up the interval, so it's between 0 and 270, but not including either 0 or 270. So it's like a strict inequality, not less than or equals to or whatever. And then they've given us this, which is a monstrosity. So what on earth do we do to solve this, my buddies? Well, what you should do, again, I really am going to encourage this, you should pause it right now. I don't think, because this is not new content, I think you could pause it and get ahead of me. And that's probably the best thing to do. So pause it and get ahead of me, and then unpause it if you're not sure. Okay, so here's what we're going to do. To start with, it's ugly because it's in that fraction. Because it's in that fraction, it's not very nice at all. So I'm going to times both sides by the denominator of the fraction. So I'll be left with cos of 2x plus 0.5 equals, and it's going to be 2 brackets 1 take cos of 2x. So just times it up. Times out the bracket, cos of 2x plus 0.5 equals 2 minus 2 cos of 2x. Sweet, let's get it in a position to solve. There's only one thing, so it's not going to be a quadratic. It's not going to be a quadratic, which is a result. So I'll move the 2 cos 2x over to the other side, and you'll get 3 cos 2x. I'm going to move the 0.5 to the other side, and that's going to be at 1.5. Cool. Now, next step. Cos of 2x, and 1.5 divided by 3 is 0.5. And that's what you've got there. And here we go. The reason I wanted you to try this question for real was, well, for number one, just so that you know how you can manipulate both sides using your same exact algebra skills, but also because, look, I've got a mixed up period one. So here we go. I'm going to do it with the cast method again, my lovelies. But again, graphs work perfectly. So here we go. Cast method is what I'm going to do because we are in a position to solve now. So pop that down like that. Sex and the city. Now, it's cos after all. It is cos, and the cos part is positive. It's equal to positive 0.5. Cos is positive here and here, which means sticks into each of these quadrants, then drop it down to horizontal, stick into this quadrant, drop it up to horizontal, and there we go. Now, no matter what the number is on the outside, I'm just going to do cos minus 1 of it. So 0.5, or whether it was negative or positive, I still would have done the positive because I want to get the acute angle out. I think that's 60. Let's check though. Shift cos 0.5 equals 60 degrees. Yeah, we guessed it right. 60 degrees. That means this is 60, and it means this is 60. Cool. Now here we go. The fun part, the part that I wanted you to really focus on is this. First answer should be 60 degrees, right? But it's not actually theta that is 260. It's actually a cos of 2x, remember. So it's not x that's 60. It is 2x that is 60. So we will have 2x equals 60 as one of our solutions. And the other solution is all the way around like that, which is 60 less than 360. So in other words, 2x equals 300. Cool. Now to save space, I'm going to use the imply sign, the mathematical implication sign. And here we go. And that means that x is equal to, in this instance, 30 degrees. And x is equal to, in this instance, 150 degrees. Cool. Both of these are within the range, which is a result. But, because this is a hard question, there is potentially an issue with the period. So let's see. Let's see if there's any more solutions that we've missed out. So here's what you do. The question, my buddies, is about cos. What is cos's period normally? Well, 360. However, in this case, it's 2x. So that means we're going to fit 2 in where we'd normally fit 1 in, because it's a horizontal squeeze by a factor of 2, or a horizontal stretch by a factor of a half. We're going to divide this by 2 because we're going to get 2 in where we'd normally have 1, which means the period's 180 degrees. Cool? Now, knowing the period, here's what you do. Take your two principal solutions and you keep adding on to it the period over and over and over and over again until you fall out of the range. So 30 plus 180 is 210. That's still in the range, so that's cool. 210 degrees. Add another 180 on top of that. Way too big, so we're too big, bigger than 270, so there's not one there. Okay. Take away 180s from them. Well, you'd go negative if you took it away from the 30, so it's not going to be there either. And then that's it. So we're done with the first solution. Second one, though, the 150. If we added on to it 180 degrees, too big, it falls out the range. Take off the 180 degrees, it's too small, it goes negative, so it's out the range as well. So our solutions are these. That's all of them. That's all that there is. And here we go. Let's see. What do you do then as a final answer to help your person who's marking you, to help your person who's going to be giving you exam marks? Well, you do this. You just write them in size order. 30 degrees, 150 degrees, 210 degrees. Final answer. Cool. So that's all I wanted to show you, just something to get your head back into the game as well. Just a little bit, something more to think about. So there we go, just on one fresh. And that's it for today's lesson. So all I want you to do is these. It's page 122, the mixed exercises, because there's two lots of questions on 222. And I want you to do questions 7, 11, 12, 14, 15, 19, 20, 21, then 17 and 18. Okay, I picked those because they look like they're tricky to me. I think 7 is a trig identity question, so you're going to be in for a bit of a rocky ride there potentially, but they are fun and they are really good. So still start on question 7 and see if you can do the proven with these two guys here, okay? And that's it from me, my buddies. Really good work on the trig unit, and I'm excited to teach you the next unit, and that's it from me. Bye, buddies!